For our case, we want state. I'm going to name it idle. Because we have created this from the idle state, it's given us a transition rule. From the try get pawn owner, we can take the pawn object reference and look for get velocity. This is a simple introduction to animation blueprints and state machines within them. By the end of the video, you'll have a character transitioning from the idle state to the moving state, playing their respective animations. Let's jump into it. So I've got a simple character that I've made here. It's a little cube. It moves around. We have a single request move action that it's playing off of. In the viewport, we can see we have a little cube. And if I hit Alt-P, start the game, we can see that we've got a little cube here. And we are going to turn this into a character that idles and walks. If I click on the skeletal mesh in the components section, we can see that the current asset is the skeletal cube. And what we're going to be using for this will be the tutorial TPP. So if I click on this, we can see it here in the viewport. And the two animations we'll be using are the tutorial idle and the tutorial walk forward. And we're going to create an animation blueprint to do this. So once we have that, we'll select it here, and in game our character will idle and walk when appropriate. Now there is a built-in tutorial TPP anim blueprint, and if we click on this, we can see the idle animation does take hold. And if we view this in the content browser and open it, we can see how this is working. There's a speed variable, a blend space, and an output pose. Also in the event graph, it's doing some logic to translate from the character's movement into a value of speed. And now if we try this in the actual game, this does not work. There is a small bug with this blueprint. It could be a fun challenge for you to dig in there and see if you can fix it. I'm going to create a new folder here, and I guess I'll call it anim blueprint to organize everything we do for this, even though it won't be much. So I'll head into the folder, right click, go to animation, and make an animation blueprint. Select this, and we have to select the skeleton that we want to use for this. And as I said earlier, we're going to be using the tutorial TPP skeleton. So we'll highlight this and click create. I'll name it ABP, or it'll just save and make me name it AB. ABP underscore animation blueprint, no, TPP. We'll double tap enter to confirm that name and open up the file. And now we have a single output pose node here that will represent what should be played at any given moment. I'm going to right click in the empty space and search for state machine. Hit enter to confirm, and I'll name this movement state. Now we can connect the output of movement state into the input of output pose. With those connected, we can double click into movement state and begin setting up the state that will drive the final output pose. From the border of the entry node, you can click and drag to place a new node. Release, and you have three options: add conduit, add state alias. For our case, we want state. I'm going to name it idle, and using the center of the node, you can drag it up and get it aligned if you like. We can double click on idle to enter the idle state, similar to how we entered the state machine. And again, we have a very similar situation, an output pose that needs to be provided some input animation. From here, we can use the Asset Browser tab. The Asset Browser lets you browse all animation-related assets, animations, blend spaces, etc. So these will be related to the specific skeletal mesh that we're using for this animation blueprint. We can drag these directly into the animation graph. Now we have our idle animation here, and we can plug it into the output of our idle state. One thing to keep in mind is when you drag these from the asset browser, they are not looped automatically. So you want to set them to a loop animation if they should be. And in this case, it should be. Now at this point, we have our idle animation going into the output pose of our idle state. Now if we go back to our movement state, we can see that we have our entry going to the idle pose. And then if we go back out to the animation graph, we have our state machine going to the output pose. So it looks like everything is connected for our idle state to play. Let's compile and see if it works. There we go. We can now see the lines activated from movement state into the output pose. Our idle state is active, and our tutorial idle animation is feeding into the output pose for the idle state. Everything's looking good. Let's return to our movement state and create our next state. Walk. And because we have created this from the idle state, it's given us a transition rule to determine when it should go from the idle state to the walking state. We'll take a look at that. We can see it's currently set to false. We'll take a deeper look at this after we implement the walk state. So for now, let's head into the walk state, and surely you know what we're going to do here. I dare you to give it a try before I do it. So very much the same thing. We've got our walk animation here. Drag it in, look for the loop, ensure it's looping, connect it to the output pose. Now let's take a look at that transition rule. Double click the same as the nodes. Can enter transition, and it's false, as we saw from the outside. So if we compile this, we do get our idle animation. The transition rule is false, so the condition is never met to go from idle to walk. Let's change this can enter transition to true and compile again and see what we get. There we go. We've transitioned from entry to idle, true, into walk. So what happens if we change this back to false? Are we going to be idle or are we going to be walking? Let's find out. We're back to idle. And that's because the state starts fresh when you recompile like this. So we went from entry to idle, we were met with a false transition, so we stayed in idle. Now let's provide some logic as to when this can enter transition should be true or false. We'll do this by going to the event graph of the animation blueprint. In here we start with two nodes, event blueprint update animation given a delta time, and try get pawn owner, so we can reference the pawn that's using this animation blueprint. I'm going to use a simple approach here to determine if the pawn is moving or not. From the try get pawn owner, we can take the pawn object reference and look for get velocity. Using the velocity node, we can ask if the velocity is nearly 0. So now we have the option of creating the type of bool we want to use to trigger this transition rule. There's two options that immediately pop in my mind. Is moving or is not moving. Which one would you choose and why? Let's create the variable that's going to drive this transition rule. I'll create a new blueprint variable in the variable section of the blueprint, and I'll name it is stationary. I'll hold Alt and drag it into the blueprint to get a setter, connect it to the event blueprint update animation, and pipe in this boolean to what it should be set to. The reason I decided to go with is stationary is because I feel like it accurately represents what I'll be using this variable for within the blueprint, and it allows me to not have to use a not boolean here before connecting it to the is stationary. If I were to name this is moving, then I would have to get the opposite of vector is nearly 0 to use the not. And once we get to the transition rule, we'll also have to use some not boolean nodes. So we can either use one not boolean node or two not boolean nodes based on our decision here. So let's implement this transition rule based on our is stationary boolean. We'll head back into our idle to walk rule, grab our is stationary variable, hold control while dragging it in to get the getter, grab the not boolean, and pass this into the can enter transition. So we can go from idle to walk when we are not stationary. Compile. Alright, let's see how our progress is so far. Let's head back to our character, and now under anim class, we have our ABP TPP. Let's select that. Nothing's really changed in the viewport. Let's compile and play the game. We've got our character idle standing there. We begin moving. The character is moving around just like we expect. But when we stop, the walking animation continues. And that's because our transition rule is only one way. But we're halfway there. Let's implement the next transition rule. Let's head back into ABP TPP, pop back up to the movement state, and drag from the outer border of walk to the idle state. And you can see create a transition is provided as the tooltip. We'll release here, and now we have a transition going from idle to walk and walk back to idle. And similar to the walk animation, I would bet you could enter this transition rule all on your own at this point. But let's head in and complete it. So we need to fill in our can enter transition output, and we want to go from walk to idle when we are stationary. So I can drag in a getter here, connect these, compile, head back out to the movement state, and everything is complete. We've got a full circle going from idle to walk and walk to idle. The transition rules, based on the naming of the variable, had I chosen is moving, we would have not used the not here, but we would have used the not here. And we would have also needed a not here to translate vector is nearly 0 to is moving. So this approach saves me one piece of logic. Not really going to change anything at all, but it makes this blueprint slightly cleaner. Let's try it out in game. There we go. The character walks while having velocity, stops walking when there is no velocity, and it's a simple transition from two states. Nothing overly complicated, but good basics to understand for animation blueprints. So now you understand the key fundamentals behind the animation blueprint and the state machines. We have the states, the transition rules, and the event graph that's driving the behavior of those transition rules. From this point, you can create many states with many transition rules, make it horribly confusing, but have a pretty awesome character transitioning between multiple states. And as far as handling the confusing part of what these state machines can turn into, subscribe and ring the bell so you don't miss my follow-up videos that will handle that for us. Until then, like this video if it was helpful, leave a comment, let me know why it wasn't if it wasn't, or if you would have done something differently. I'd love to hear what your approach would have been. And sign up for my newsletter in the description to get access to any builds that I release, because I've got a pretty awesome one coming up.